Moving on to piecewise functions. So when we graph a piecewise function, we need to graph the magic lines. The magic lines are right up here given in the domain restrictions. So we've got a magic line at -3, so 1 to -3. And remember, these are just boundaries, so you know where your graphs go. And a magic line at +3, 1, 2, 3. So there we go. So first piece of the function, I'll do it in blue. It simply says f of x equals 5. Remember, f of x is the same thing as y. So y equals 5 when x is strictly less than -3. So 1, 2, 3, 4, 5. Open circle at -3. And we will graph the line to the left. Next, I'll do the next piece, the middle piece in orange. We have a slope of 1, a y-intercept of 3, and we can use that because we can actually get to the y-axis in this middle piece of the piecewise function. 1, 2, 3. I'm going to put in that y-intercept. The slope is 1. And since it's or equal to on both of those sides, when I get to the magic line, I can put a solid circle. And there is my middle piece of the function. And I'll do the last piece, strictly greater than 3. It is 2x. So I could even put 2x plus 0, and then maybe make myself a little xy chart if that's helpful. So a number bigger than 3, of course, is 4. So when I plug in 4 into the function, 2 times 4 is 8. So 1, 2, 3, 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. Slope is 2, up 2 over 1, up 2 over 1, down 2, back 1. So this is where the two functions actually come together. It's kind of like they're holding hands. So there you go. That is how you graph a piecewise function. Got a few more graphs on here that we'll have in this little video. So we've got y is equal to -2 times the absolute value of x minus 4 plus 5. So a brief reminder here. Anytime that we have any sort of addition or subtraction inside the grouping symbols, this creates a horizontal change. And the easiest way to deal with it is to simply take everything inside of the grouping symbols and set it equal to 0. So when we do this, we see that this graph is going to move 4 to the right. It's going to the right because it's positive. Now, everything outside of the absolute value is going to create vertical change. So the plus 5 on the end, that's the easiest one of all. That's your vertical shift. And then the -2 up front is going to make what normally is a V that's open at a 90-degree angle, it's going to tighten it up and stretch it vertically. So this creates a vertical stretch. And because it is negative, it is going to open down looking like that. So now if we're going to graph that, and we have a horizontal change of 4 to the right and up 5, 1, 2, 3, 4, 5. So there's the point where we're going to start. And once again, if you want, you can make a little XY chart once you get that first point. So what do we get if we plug in 3? Let's find out. 3 minus 4 is -1. The absolute value of -1 is 1. 1 times -2 is -2. And -2 plus 5 is 3. So when x is 3, y is 3. Over 3 and up 3. Which makes sense because this absolute value graph, which is normally open at a 90-degree angle, is squeezing some because of a vertical stretch. So what we really can do and make this easier on ourselves is use that A value. We've seen the A value in the parabolas. Use that A value as the rate of change here. down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. That is the quickest way to deal with an absolute value function. So there is y equals -2 times x minus 4 plus 5. Next, we have a system. Oh, we should do domain and range before I get away. Domain, please note, this goes to the left forever, this goes to the right forever. The domain is all real numbers. And the range, remember the range is read from the bottom to the top. This graph has a top value right there. 1, 2, 3, 4, 5. So my top value is 5, so that means my range starts at -infinity and goes up to and includes 5. So this is an interval notation. You might also see it on our test in algebraic notation. We would simply say, since it is the range, y is strictly less than or equal to +5. So both of those are ways to describe the range values. All right, now the system. 3x minus 2y is greater than 10. X is less than or equal to -1. So let's do the first one in blue pen. It's going to be a dashed line because it is strictly greater than. And I think the first thing I'm going to do is drag it right down here because we need to solve it for y, get it in slope-intercept form. That's the easiest way to graph. So if we want to solve for that y, we will subtract 3x and get -2y is greater than -3x plus 10. Next, from here, we are going to divide everything by -2. And please recall that if we divide by a negative, we got to flip that sign. So we are going to end up with y is less than, strictly less than, -3 over -2 is +3/2 x, and 10 divided by -2 is -5. So here's our first line. 1, 2, 3, 4, 5 down, slope of 3 up 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. And once again, remember it will be dashed or broken. Anytime we have inequalities, you need to do a test value. So let's plug in 0, 0 in, remember, x0, y0, here and there. 3 times 0 is 0, 2 times 0 is 0, 0 minus 0 is 0. Is 0 greater than 10? That's a no. That means we will shade away from 0, 0. So there's the first line. The second line I will do in orange, and it is the easiest one of all to graph. It simply says x is less than or equal to -1. Well, where is x equal to -1? It's right here. So what we're dealing with here is a vertical line. And because of the or equal to, it will be solid. So here's my vertical line. X is less than or equal to -1. So plug in 0, 0. Is 0 less than -1? It is not. So we are going to shade away from 0, 0. 0, 0 is right there, and it is not shaded either time. Now, I actually need to extend my line right here and my shading right here because we're trying to find where's the shading happening twice. And it's actually happening twice right down here. I will highlight it in this squishy little area right there. The points in that area on the bottom of this picture will make both of the inequalities true at the same time. Therefore, this particular little region is what is shaded twice, and that is the solution to the system.